Hello, everyone. So we have two other geometry problems on a state test. So we have three circles inside of the larger circle, and the question asking the largest possible value of the ratio of the total shaded region to the area of the largest circle. Okay, and we want to find that. So this is going to be the largest if those three smaller circles are going to be tangent to the largest circle inside, and all those three smaller ones are tangent to each other as well, which is the given already. So like whenever we are dealing with these circles, usually it's it's good to kind of find the center points and connect with the some intersections so we can get some shapes that might be easier to deal with. So which is why I'll do that as well. Okay, so if I connect these, right, so I will get a equilateral triangle because this is gonna be like those three circles are just the congruent. So then the radius will be the same. Since we don't really have the numbers, we just come up with some numbers just to make it a bit better. But instead of choosing the numbers right now, I'm gonna just continue finding something else as well. So we also need to know the center of the largest circle. Let's say this is the center of the largest circle. And if I want to connect this to the tangencies, okay, so maybe I can draw this radius, which will be what I need as well. So maybe I can call that is like capital R, or in the other one is like smaller one. But let's think about this a bit more as well. So since like when you take this center and connect to the tangency line of tangent, then the angle in between is 90 degrees, right? So which is I can draw that. So this guy right here is 90 degrees. And like since we have equilateral triangle, the angles are 60. So I can say this is 60 degrees and this is 60 degrees. And if I want to connect the center of the larger circle to the center of the smaller circle, I do get a nice 30, 60, 90 triangle. And if you are not sure why this is the case, like I do need you to look at the tangent properties. So like if I take the analogous segments from the center of the large circle to the other tangent point, for the smaller circle, we do have congruent triangles. They are equal to each other. So this guy and this guy are equal to each other. And this is the same as this one. So we do have two congruent triangles. So which is why the angle right here is 30 degrees. And this is also 30 degrees. Why do I need that? I'm going to use different color. Because I do need to like see some ratio and 36 and 9 is one of those good ones that we can use. So now we are almost there. So like if I call the side that is opposite 30 degrees like x, then the side that is opposite, which is like 60, is gonna be x root 3 by the properties of the special right triangle. And the hypotenuse, which is gonna be this piece, will be twice as much, which is 2x, right? And why this is important? Because I do know now, if I extend the radius to the tangent point, and I do know the radius of the smaller one was x root 3, so this is going to be also x root 3. And now we are almost there. So we do need to find the area ratio of the sum of those three smaller circles, which will be the radius is just x root 3. So let's go ahead and do that. So the answer is going to be pi times x root 3 to the second power. That's the area of the one of these smaller circles. But we have 3 copies of this. And this divided by pi times area of the largest circle. The radius of the largest circle, if you remember, it was like 2x plus x root 3. So that was the radius of the larger circle. So which is why we're gonna write that. So 2x plus x root 3. And since we can like take the x's like out of the expression because they will be cancel each other anyway. So we can just deal with the remaining part. So that, and then pi's will also cancel each other. So you will get 3 times. So root 3 squared, just 3. And that's the numerator. And the denominator would be 2 plus root 3 to the second power. And that will be 9 over. And if you square the 2 plus root 3, you can use the square of binomial or just expand it, multiply by twice. So you will get 4 plus 4 root 3 plus 3, and that will be equal to 9 over 7 plus 4 root 3. And we do need to simplify this. We are going to multiply this by its conjugate. So that will be 7 minus 4 root 3 and 7 minus 4 root 3, right? And if I multiply the numerator, you will get 63 minus 36 root 3. But the denominator is going to be nicer because 7 plus 4 root 3 and 7 minus 4 root 3, which is the difference of square. So you will get 49 minus 48. And if you don't see why we got this immediately, you can just multiply 7 by 7, 7 by negative 4 root 3, and 4 root 3 by 7. Those two middle terms will cancel. And then 4 root 3 and negative 4 root 3 will be 48. So the number is just 1, basically. So 63 minus 36 root 3. So this is our final answer. But in this form, so we just need to find ABCs, basically. And if I just plug these, so I will get 63 and minus 36 and plus 3, basically. And that is equal to 30. So this was number 6, which wasn't too bad. Like just connect the center point to the some tangencies. That is what we did. And that was the number 6, okay? So let's look at the next problem. So this is number 9 on the same test, which was maybe challenging looking. So we have given like AB as 4. So let's go ahead and write that. And BC is 12. So I'm going to write it 12 for BC. Okay. And AE is 2. That is given 2. And segment EG is given. So just connecting 2 points on BC and AD. And the area of the trapezoid, let's look at this part. ABGE is 1/3 of the rectangle ABCD. So the ABCD is like 4 times 12. If you take the 1/3, so you will get 16. So the area of the like AEGB is 16, but we do know that's a trapezoid, so we do need to multiply the height by the average of the parallel sides, so which is like 2nBG. And if you take the average of those two sides and multiply by the height, we should be getting 16, right? So that means I can cancel these. So that's 8 equals 2 plus BC, BG. And that is gonna be 6. Okay, this is good. So we got BG as 6, and that means GC is also 6 because we do know BC was 12. So that might be useful. And what else we are given? We are given that there is another segment, which is FH, that is given parallel to the BC or AD. And the area of those two like trapezoids are equal. So we are told GCHF and FHDE have equal areas. Okay, and we want to find the FH. So the question is slightly challenging after this moment because there is nothing really much going on, is always given. What we can kind of use, we are given the area is equal, so we should use that somehow. But it doesn't look like we are having too much information to use that. So here's what I'm going to try. So like we have like 6 and 6, right? Maybe that is useful for us to use it. So what I'm going to try, I'm going to extend the I'm going to extend the segment so we can get some sort of triangles, because usually similar triangles are useful. I'm going to extend EG in a way that will intersect with CD when I extend it. So if I do this, so it will be something like this. Then if I extend CD, and I do get this figure. So it doesn't look great, but let's try again. Okay, so this is the segment. And why do I need that? Because the similar triangle is useful. And I'll do the same thing with the BA. Okay, so if I do this, and then if I extend the FD to intersect with that, so I do have this one. Okay. Okay, so now this is good. So like, so whenever we look at the, let's say this is T. Okay, and then I'm gonna call this is like K. So like if I look at the triangle B, like BGT, and C, like CGK, they are similar. They are not just similar, they are congruent, because they have the corresponding parts as 6 and 6, which is why they are equal. So that is something we have. And also, I can say if I name this is X, right? And X plus 2 is going to be TB. That should be same as KC, which is also X plus 2. The reason why that's the case, because this triangle and this triangle are similar. They are also congruent. Okay, not just similar, because the corresponding parts are 6 and 6. Okay, how this is going to be useful? So like, we do also have another triangle that is also similar. So what I mean by that, like if I take a look at this triangle, right, and then this triangle, so let me draw that. Like this one and that larger one is also similar. So whenever you have some intersection, this is common like types of the similar triangles. So we do have that similarity as well. And I also know this is gonna be same as AB, which is 4. And now we can write the ratios. So we have X as the AT divided by KD, like which is gonna be 4 plus X plus 2. So that's my corresponding side. And this is equal to AE, which is 2, divided by ED. Well, we do know ED is 10, so I'm going to just write that is 10. And if I simplify this a bit, maybe I can simplify first before we cross multiply. So you will get 5x equals x plus 16. So the 4x will be 16. X is 4. So let me double check with that part. So the 4 and x plus 2. This was actually x plus 4, so I should check that. That's x plus 4 and x plus 8. 5x equals x plus 8. So that should be that. 4x would be 8. X will be 2. Okay, I checked. I did something wrong. I fixed anyway. So that is 2. So then, which might be reasonable to say that was equal to 2, because we have the larger triangle was like 6 and 4 on the other side. So that was kind of obvious for some individuals. But now we prove that is actually the 2. So then how this is going to be useful? So x plus 2 will be 6. The area of that triangle will be 18. And we already know the area of the both trapezoid is like add up to like 4 times 12 minus the area of the left trapezoid was 16. Okay, because AEGB was area of 16. If you subtract, you will get 32, meaning that this is 16 and this is also 16 in terms of area. Okay, so as a last step, I'm going to try to use the area of two similar triangles in terms of its base, like similarity ratio. So if you have two figures are similar, the area ratio is the square of the similarity ratio. So like if I take the, let's say this is X unit, actually I should choose something else. Let's say this is Y unit for CH. And we do have similar triangles as well going on. So which one are those? Like, let me just draw it separately. So if I draw this, okay, so this is 16, this is 18, and this is 6, and this is 1. Like, since we have these two guys are parallel, so we have those two triangles are similar. So KGC and KED are similar, and the ratio is 6 over 6 plus y. Okay, so we can use this information. So 6, okay, so let me, like 6 over 6 plus y. The square of this ratio has to be area ratio. So the area of this, the top triangle is 18, area of the total is 34. And this area ratio should be square of the ratio of the similarity. And if I simplify this a bit, you know, I do have some simplification. This is 9 and this is 17. Instead of like squaring the left side, I want to take the square root of both sides. So you will get 6 over 6 plus y equals 3 over root 17. Maybe I should have done this at all because I don't really need y value. I do need the FH. Maybe I should use that instead. So, but if I finish this problem, I will get the y value as soon as I have the y value, and then I can use the 16 because area is given to get my FH. Let's do that because I start with this anyway. And this can be simplified. So you will get y plus 6 equals 2 root 17. And which is going to give us 2 root 17 minus 6 for the y value. And the area of the GCHF is just the trapezoid. So we just remember that is 16 is equal to y value, which is 2 root 17 minus 6 times the average of the bases, which is 6 plus FH divided by 2. And this is the equation that we have to solve for to get FH. And if you do so, like we are gonna, like, I can cancel 2s, I can cancel by 2, so you will get root 17 minus 3. And if I divide both sides by root 17 minus 3, 16 by that will be my fraction, and then I will subtract 6 after. So the FH is gonna be 16 over negative 3 plus root 17, and we will subtract 6 after. Okay, so it looks too complicated already. If you just multiply the fraction by minus 3 minus root 17, because we want to cancel that irrational part. So we should be okay. So let's check and see. FH is equal to 16 times negative 3 minus root 17 over, if you multiply the negative 3 plus root 17 and minus root 17, so you will get 9 minus 17, and then we have minus 6 after. And this is equal to negative 8. And I can cancel this, which is going to be negative 2. If I expand those, you will get 6 plus 2 root 17 and minus 6. So these will cancel. So you get 2 root 17. So that is my final answer, which was in radical. So 2 root 17. Again, I should have done this a bit differently. It's like I could just use the FH and GC instead for the, like this part. Then if I did that way, so that will be a bit better. So let me show you what I mean by that. So I'm gonna try it as well. So like as soon as we had this triangle, instead of using the y value to get what we want, we should just find the FH. Okay, so the ratio would be this. You know, GC is 6 units, so that means I can just write like 6. So like that. So 6 over FH. This is the ratio of the similarity. And then if you square this, you get the area ratio, which is equal to 18 over 34. And if you simplify those, you will get 9 over 17. And if you take the square root, so you will get 6 over FH equals 3 over root 17. Right? And then if you do cross multiplication, so 3 times FH is going to be 6 root 17 divided by 3. So FH is 2 root 17. And we are done. So this is way better than the other part. Like I just find the CH first and then use the area to get the FH. That is also okay, but it took a bit longer than it should. And that is what we have. Okay. I hope that makes sense. I'll see you in the next video.